So today I want to talk to you about SRE versus DevOps. Are they competing standards? Are they friends? Are they the same thing? Are they completely different? Where do they overlap, etc. My name is Seth. I'm a developer relations engineer at Google. Prior to Google, I worked at companies like HashiCorp and Chef Software. And primarily my job at Google and previously was a software engineer who occasionally gets on a stage and talks about cool things and like architecture and things like that. So you may recognize me from the DevOps versus SRE video series that I did, which is a 10 video series where we go in depth into a lot of the topics that I'm going to cover here in about 25 to 30 minutes. So the content we're about to cover is by means not like exhaustive. It's not the only information out there. There's a bunch of information that you can find through the video series and the blog posts that we've done. This is more of just an overview. But before we talk about SRE, I want to talk about DevOps. I've heard the term DevOps a lot at this conference. It was mentioned in every keynote. It's been mentioned in most of the sessions. But I want to make sure that we're all on the same page. So what is this DevOps thing? Because depending on what you're doing and who you are, you kind of have a different definition. And for the purposes of this presentation and in my personal experience, I'm like a DevOps purist. So DevOps all started with developers. Developers were focused on agility. They're focused on moving quickly. They're focused on delivering their code to their users or into production in some way, shape, or form. And then on the other side, we have operators or sysadmins or whatever you want to call them. And these are the people who are responsible for stability. They're responsible for keeping the system up and running at all costs. They're the ones who get paged in the middle of the night when something is broken. They're the ones who have to make sure that the system is up. And when the system is down, it's their fault. It's not the developer's fault. But what was interesting is that the way that these organizations were structured, and I'll talk about that more in a little bit, is that developers would often just throw their code over kind of this metaphorical wall or physical wall to the operators. And the operators were responsible for keeping this code up and running. Now, there's a few key cultural areas here that are important to discuss and touch on. First, developers oftentimes, these are generalizations, but developers oftentimes had a very traditional, rigorous university background and education. They might have a degree in something like computer science or software engineering. They likely went to a 2 or 4 year plus university or college to obtain that degree. They were often physically closer to leadership, meaning they were physically in the same building. Oftentimes their directors or their vice presidents were on the same floor or 1 or 2 floors above or below them. And they had a very close tie-in to the product organization and to the business value of the company. They were delivering business value. They were improving features, adding new features, bringing new customers to the platform. Operators, on the other hand, tended to come from more of an associate's degree background, or they were self-taught, coming in through a traditional IT channel, such as like laying network cables or repairing hard drives, kind of the traditional IT side of things. They were often physically disconnected from the business. They often had their offices in the data center, in the corporate data center. They were physically disconnected from leadership, which sat at the corporate offices with the developers. They often worked very different hours because downtime and scheduled maintenance, et cetera, can only happen in the middle of the night. So a lot of these operators actually worked nocturnal schedules, very similar to like a doctor or a nurse who would work night shifts in order to be able to do maintenance and things during planned downtime whenever customer usage was low. And they very rarely delivered value. The leadership didn't really consider, we upgraded all of our RAID hard drives to a newer version, or we racked 12 new servers this month. That wasn't like an OKR. That wasn't something that brought value to the business in the eyes of the leadership at the time. So it was very difficult for them to make a case for why they need help, why they shouldn't be running these applications. And if we remember that developers traditionally have like a software engineering background, operators typically didn't, yet they were responsible for making sure that this code kept running. So that meant that if there was a bug in a developer's code, an operator who didn't have a background or a software engineering expertise was responsible for debugging that, getting paged in the middle of the night, figuring out what was wrong. And then when they would go back to the developers and say, hey, your code is broken, the developers would say, no, that's your problem. That's not my problem. And as you can imagine, this created a lot of tension, right? You have a group of people who are focused on agility and delivering new features, and you have a group of people who are focused on stability, and the easiest way to make things stable is to not change anything. So inherently, we're introducing change into the system, making the operators' lives difficult. On the flip side, though, operators had a lot of knowledge about things like distributed systems and networking and throughput and bandwidth and capabilities of the underlying systems, especially for companies that were running in their own data center stacks. And that information wasn't getting back to developers. So developers would write a little algorithm. It would work great on their MacBook Pro or their Dell laptop. They would push that into production and it would fail. And that's because they had no idea, and this is a true story, they had no idea that like the maximum network bandwidth in their data center was 10 gigs per second. And on their local laptop, when everything's in memory, by all means, like you can do hundreds of gigabits per second. But the moment you have to transmit that over a network, you now have network latency, and they didn't understand that. They didn't think about that, and that cost a particular company hundreds of thousands of dollars because they had to rewrite an application. So DevOps, in like the purest definition, is about breaking down the barriers that exist between developers and operators. It's about either physically breaking down the barriers, meaning putting them in the same physical room, or it's about metaphorically breaking down those barriers, making sure that we're sharing knowledge and making sure that operators are part of the development process and making sure that developers are part of the incident process and the operations process. So there's a few ways in which companies do this or accomplish this. The first and like the most obvious one that I've seen successful is that you put them in the same room. This is like a very non-technical approach, but it turns out that if you put humans in the same room, they start to communicate with each other. They start sharing knowledge. The challenge is that then how do you get executives to buy into this? Right? How do you we go back to the earlier conversation around how VPs didn't really see value in operators because they're just introducing stability. They're not bringing new features. They're not bringing new value. Well, by partnering with developers and by developers partnering with operators, we started to build a new class of operator. We started to build someone who had a lot of knowledge about clouds, a lot of knowledge about performance, and a lot of knowledge about distributed systems. And that's whenever we started to really bring value to the business. So if you think about the kind of the DevOps movement, depending on who you talk to, there are anywhere from 5 to 500 key areas that you can focus on. But it's my talk, so we're only going to focus on 5 of them. The first key barrier or key piece of the DevOps movement is to reduce organizational silos. This is a very big piece, and I think like the most important piece of the DevOps movement is that in order to facilitate a true kind of DevOps movement within an organization, we have to reduce or completely eliminate organizational silos. And originally, this was between developers and operators, DevOps. But very quickly, what you'll learn is that if you're able to eliminate, let's say 95% of the friction that currently exists between your developers and your operators in your organization, you're going to start to find other areas where friction exists. The most logical next step is security, right? So you reduce all of this friction between developers and operators. You're rapidly accelerating code delivery. They're partnering together, writing very efficient algorithms that are made to run on your bare metal or on your cloud provider. You're ready to ship, and then security comes in and says, "Whoa, what are you doing? You haven't included us in this process at all. We'll let you know in 6 weeks whether you can deploy this or not." And you're back in the same boat that you're in before, where previously operations was saying, no, please don't deploy code. Like, we can't handle it. Like, we're in the middle of a migration. We need to review your code before we can put it on these servers. All of a sudden, you got past that hurdle, right? All of a sudden, operations and developers are working together. They're in a moment where they can do continuous deployment, and then security comes along and says, no, you didn't involve us from the beginning. We have no idea what this is. We need 6 months to review it. And then you get over the security hurdle, and all of a sudden marketing comes in and says, whoa, we didn't prepare a press release for this. We need 6 weeks. We got to write a press release, right? It's this continuous movement where you'll break down that barrier between developers and operators, and then you'll find the next barrier. So the more flat that your organization can be, whether that's, you have horizontal functional groups where every product has a marketing person and an operations engineer and a developer and a product manager, or if you just really have good communication across those teams and good trust, that's one of the key areas for the DevOps movement, is really breaking down those barriers as much as possible. There are natural barriers, right? There's barriers that exist between layers of management. There's natural barriers that exist because of technical expertise or domain expertise, but reducing them as much as possible. And you'll notice it doesn't say eliminate, it says reduce, because you're never going to completely eliminate organizational silos. But we want to reduce them as much as possible. The second piece of the DevOps movement is that computers are inherently unreliable. And we can't expect perfection. Humans are inherently unreliable, and we can't expect perfection, and humans have built computers. We have to accept failure as normal. If we go back to the earlier kind of conversation around operators, one of the areas that was very difficult for an operator was that if there was downtime, their job was at risk. If the bank's data center was down because of a bad code deploy, they ran the risk of getting fired or put on a probation plan or something like that because there was downtime, even though that was completely out of their control. And that was because organizations valued 100% uptime over the value of their own employees, but also because organizations didn't understand that failure is going to happen. And that by creating a culture where people are fearful of trying new things and of taking risks, that they're inherently slowing their own progress. So we have to accept failure as normal. And this is really another key piece of the DevOps movement where you'll start to hear people talk about things like blameless postmortems and retrospectives. And those are all like very concrete ideas. But the high level, like 30,000 foot view is that like stuff is going to break. That's a guarantee in kind of distributed systems in the cloud and anything, especially if you're not controlling your entire stack. So we have to accept failure as normal. Another piece of the DevOps movement is to implement gradual change. One of the things that we found was that organizations, because they were only deploying every 6 months because of big organizational silos or big checkboxes or because of fear, was that they were deploying 1 million lines of code or 10 million lines of code. And if one of those 10 million lines of code had a bug in it, you had to roll back the whole thing. And this leads to very, very, very infrequent deploys. It leads to very, very, very infrequent value delivered to your customers. And it makes it really hard to find a bug in 10 million lines of code. And this is why oftentimes you'll see people talk about DevOps and like CI and CD, continuous integration and continuous delivery, in kind of the same sentence. But that's really like CD is just one part of DevOps because we want to implement gradual changes because they're easier to review. We want to deploy gradual changes because we can catch them and quickly repair them instead of deploying hundreds and thousands of lines of code at a time. It also helps us with mean time to recover, which is the MTTR, which is a metric that you'll often hear kind of in DevOps circles, is that by reducing our mean time to recover, we reduce downtime that our customers experience. We're deploying a new feature, oops, there was a bug, we can quickly roll back just that feature. Versus, oh, we deployed a whole new version of the platform, and it took 10 days to roll out. Now we have 10 days of it unrolling out because we have no idea where the bug is, and we have no idea how to do a quick rollback. Another piece of the DevOps movement is to leverage tooling and automation. And I think that this might be very relevant to this audience, but kind of everyone in general, is that a lot of people conflate the DevOps movement with like Chef and Puppet and Ansible and Salt and shell scripts and Bash, because you look at these companies, companies like HashiCorp, companies like Chef and Puppet and Ansible, and it's very easy to think of those as DevOps tools. In fact, I think Gartner might even classify them as DevOps tools. But the real thing, like the real piece of the DevOps movement is that we should leverage tooling and automation. It doesn't say which tools, it doesn't say which automation, but as we start adopting cloud technologies, as we start managing, hundreds and thousands of devices and servers, it's no longer efficient or even manageable for a human to be manually provisioning those machines. We need automation. We need automation for consistency. We need automation for knowledge sharing. Right? Because a wiki that runs from shell scripts is far less efficient than a Chef script or a Puppet module that just does the thing automatically. And the last piece of the DevOps movement, in my definition of the DevOps movement, is to measure everything. It doesn't matter if you're successful in all 4 areas. If your boss or your manager comes to you at the end of this 6-month trial of adopting DevOps in your organization, and your manager says to you, hey, were you successful? Without concrete measurements and concrete metrics and criteria, you can't answer that question. And that means you have to be measuring things before you start adopting DevOps, while you're adopting DevOps, and throughout the entire journey. I see a lot of organizations who, they get executive buy-in for a small team, right? A large enterprise, a small team gets some budget and some leeway to really go explore this DevOps thing, go explore this SRE thing, this ProdOps thing, whatever you want to call it. And they spend, 6 months to a year rapidly delivering value to the organization. Like, it's abundantly clear that they are outperforming everyone else in the organization. But then performance review time comes along and just retrospective time comes along, and they have no way of numerically proving that they have bettered themselves among any other team, because they're not collecting metrics. They're not collecting metrics about their own processes. They're not collecting metrics about their applications and services they're supporting. So none of this is beneficial if we're not constantly measuring everything. Now, we'll talk about this a little bit more in a bit, but just because you measure something doesn't mean you monitor it. And just because you monitor something doesn't mean you alert on it. Just because you alert on it doesn't mean you page on it, right? There's a giant kind of like Venn diagram of circles here, right? So just because we're measuring something, that doesn't mean that we're, creating some actionable PagerDuty alert on the other side of it. I see a lot of organizations get carried away here. Some of this is probably relevant to you all because if you don't control your software supply chain, for example, you haven't accepted that failure is normal. So if you're relying on Git, but you have all your source control stored in a centralized repository, you haven't accepted that failure is normal, right? Because if that central repository goes down, it's difficult for your developers to push code. If you store all of your packages on something like RubyGems or PyPy or NPM, you have introduced a single point of failure into your system, and you have not accepted failure as normal. So a lot of times I talk to people, and they're like, oh, we're doing DevOps. And I'm like, great. Are you using Artifactory? And they're like, oh, no, we use NPM.js and GitHub.com and these things. And it's like, well, if you don't actually own your availability, you haven't truly accepted failure as normal. And maybe you're only using those tools as a fallback, or maybe you have an on-premise version, and then on the cloud you're using something different. But you have to accept failure as normal, and that really means controlling your entire software delivery supply chain, including artifact management, including build process, CI/CD, the whole thing. One of the things you'll notice here is that I haven't really talked about specific tools, right? I mentioned Artifactory, I mentioned Chef, Puppet, Ansible, and Salt, but nowhere in the kind of any of the DevOps literature you read will you see something that's oh, you must use this tool to do DevOps. If you just adopt Terraform, you're doing DevOps. It doesn't work that way. And if you zoom out even further, you'll notice that all of these, reduce organizational silos, measure everything, implement gradual change, they're all very, very, very abstract ideas. They're not concrete implementations. The DevOps principles don't tell you how to reduce organizational silos or how to reduce mean time between failures. They just say that you should. Because of this, you can think about DevOps as an abstract class or an interface in programming. It defines the end result, but it doesn't actually say how you get there. And it's up to every organization to define their own implementation. And in my experience in talking with customers and users and speaking at conferences and meeting with people, the biggest challenge organizations have is they look at this list of things and they have no idea where to start. They have no idea how to implement DevOps because a lot of companies, especially large enterprises, just want a checklist of things that they can do. They want a list of things that they can adopt, a list of practices they should follow. And DevOps is much higher level than that. It's 30,000 feet instead of 5,000 feet. So independently of DevOps, around 2009, Google started developing this thing called SRE, which was Site Reliability Engineering. You didn't hear about it in 2009 because Google largely regarded site reliability engineering as a trade secret. They didn't talk about it publicly really until 2014, 2015, mention it publicly, and we didn't really talk about it publicly until 2016, 2017. You would never find a job posting for an SRE back in 2009. It was just software engineer. You would never find a white paper or a blog post. You might find like an internal text message between some folks, but like it was largely regarded as a trade secret internally, because we felt that SRE, both the discipline and the job description, gave us an advantage over other search engines, other ad companies, other clouds. But very quickly we learned that SRE is actually a concrete implementation of the DevOps interface. Now, like my legal team and like the brand core team wants me to emphasize that like SRE was not created to satisfy the DevOps interface. They evolved independently, but when you zoom out and look at it, SRE actually implements many, if not all, of the concrete pieces of the DevOps interface. So I want to walk through those with you and then kind of jump into some more detail. So we talked about reducing organizational silos. And I said, in my experience, the best way to do that is to put them in the same room. Put your operators or your SREs and your developers in the same room. The way that SRE actually does this is that they force a shared ownership model with developers. So the SRE discipline, right, the site reliability engineering discipline, forces a shared ownership with developers. We do this through error budgets. We do this through using the same tools and technologies. So at Google, and what's recommended in the site reliability engineering book, is that developers and operators should be using the same shared set of tooling. If you have a command that does something, that debugs something in production, that same command should be available to developers. If developers are running some build process or some local CLI tool, that should be available to operators. All of this should be the same shared set of tooling so that operators can add improvements and developers can add improvements and learn from one another. We also accept failure as normal. Part of the SRE mantra at the core of SRE are these things called SLOs, which are service level objectives. Service level objectives they're kind of like your internal SLA. They're, we'll talk about them in detail in a little bit, but they're an integral target to meet for the availability of your service internally. It's what you advertise to your consumers internally within your organization about the availability of your service. And the way that we define an SLO is based off of how much risk and failure tolerance an application or service can have. As you might expect, SRE also highly advocates for blameless postmortems and retrospectives, but SRE also advocates for meta blameless postmortems and meta retrospectives, meaning do a retrospective on your postmortem. So you have one postmortem with one outage. And oftentimes you'll have hundreds of minor outages, especially in a large organization over the course of a year. The SRE discipline actually advocates for taking all of those together and then analyzing them and making large kind of meta decisions or macro decisions and analysis about your organization. This is how, like, for example, at Google, we know the vast majority of our outages are caused by configuration changes, because not only do we look at one isolated incident and do a postmortem, but then we have a team of people that analyze those postmortems and create macro observations. And then from there, you can have organization-wide change, like checks in place to make sure that you're not repeating the same patterns over and over and over again. Implement gradual change. The SRE model really strongly encourages moving fast by reducing the cost of failure. That means fast deploys, fast rollouts, and fast rollbacks. Part of SRE is actually planning a failure before you deploy. So you're about to do a database migration, you're about to deploy a code change. Before you do that, you have to plan the rollback. That way, if it fails, you're not sitting there scrambling at the last minute trying to write a script. You've already written a script to rollback that is already tested and has already been peer reviewed. That way, if the rollback fails, we've planned for failure, which goes back to the previous example, but we're only implementing small and gradual changes. Part of the SRE model is definitely to leverage tooling and automation. A little bit different though. Like I said, at the organizational silos, we all share the same set of tooling, and you can add new tools and deprecate tools as needed. But one of the key pieces of an SRE's job is to automate this year's job away. So if you spend an entire year restarting servers, which you probably should not do, next year it's your job to automate that and make something like Kubernetes that restarts your servers for you. But also, we have this thing called toil, which we'll talk about in one of the later slides. toil is like work that's devoid of long-term value, and we want to minimize that as much as possible. And this is where automation is really, really helpful, because we can leverage tools that scale, that give us insights and metrics, speaking of the next thing, into the way that our systems are behaving. And lastly, SRE encourages measurement. It encourages measurement not only of our systems, but of the human factors in our system. We measure things like reliability and uptime, but we also measure toil. And we fundamentally believe that operations is a software problem. That we can use software technology, software algorithms, machine learning, and those types of things in the operations world. And this is really a key piece of site reliability engineering, is that it's really bringing the software engineering discipline into systems management or systems engineering. So hopefully that's a little bit clearer why we say class SRE implements DevOps. And one of the things I like to note is that if you adopt SRE, you're not going to have 100% uptime. We'll talk about why 100% uptime is a bad target in a second. But SRE is just one way to implement DevOps. It's a concrete implementation, but like VictorOps has a thing called ProdOps, which is another concrete implementation. So my goal here is to just give you information to make a better decision. I'm not trying to like sell you on SRE. And to prove that to you on camera, how many people here use Google Calendar? How many people could use Google Calendar today? Yeah, we had a massive global outage today. And we have one of the best SRE disciplines in the planet. So it's not like, oh, adopting SRE is going to make you the best, the greatest, the most amazing. You're still going to have downtime. You're still going to have outages. But hopefully you can recover from them faster. So let's go and kind of drill into some of those concepts that I talked about a little bit deeper. SLIs, SLOs, and SLAs. Oh my. Teams are constantly putting out fires, many of which might end up being bugs in developers' code. When they push back on product teams, or the developers, like whose responsibility is that? How do we manage all of that? This is a very classic DevOps problem. But before we get into that, let's talk about SLIs. So SLIs are service level indicators. These are often like a metric like request latency or requests per second or failures per request that are usually aggregated over some short period of time and then converted towards a rate, average, or percentile within some threshold. So for instance, you might say something like, oh, the 99th percentile request latency must be less than 250 milliseconds, or something like the ratio of 500s to 200s must be less than 1% over the past 30 seconds. Then an SLO, the service level objective, is an integral of the SLI over time. So the SLI is a binary operation. It's either up or down, yes or no, right? Is at this moment in time or at this integral in time, is the system healthy or not? The SLO is then an integral, if you remember kind of from calculus class, it's an integral of those SLIs over a defined time period. Could be 6 hours, could be 30 days. Whatever your target availability is. For instance, we might say that we want the 99th percentile latency for the SLI described on the previous slide to be correct or up 99.9% of the time for a particular quarter. Then there's this service level agreement, which is probably the one that you all are most familiar with or you've heard most frequently. A service level agreement is a contract or a business agreement between a customer and a service provider that is typically based on an SLO, but this is mostly used as part of a sales engagement or risk recovery mitigation in a legal discussion. So SLIs drive SLOs, which then inform the SLAs. So it might be a little bit easier to show this kind of with people. So in the SLI world, you would have a product owner, a site reliability engineer, and a software engineer collaborating to define these SLIs. These are the key metrics that determine whether our system is up and down at any point in time. Then the SREs and the product owner would work together to build the SLOs. Are we targeting quarterly? Are we targeting every half? Are we targeting yearly, monthly? Which ones are important and which ones are secondary signals? And then the sales team would work directly with the customers to assign an SLA to that, maybe involving the product team, maybe involving the software team if the customer wanted a really tight SLA. But the idea is that the SLA is always more broad than the SLO, because you always want to break yourself. You always want to break your own internal monitoring and your own internal promises before you break that of a customer. So for example, you might have an SLO of 5 or 6 nines of availability, but you may have an SLA of 3 or 4 nines of availability. That way you're breaking your own internal systems before you have to give money or credits back to a customer. So striving for 100% availability isn't just irresponsible, it might be impossible. Maximizing our stability limits how quickly we can deploy new features and functionality. And the vast majority of our users, star we'll come back to in a second, don't notice extreme availability because they're governed by less reliable systems. So little star, there are areas in which this doesn't apply, particularly in healthcare and aviation, where 100% availability is a really good target. But for the vast majority of the things that I would imagine most of the people in this room are working on, your users will not notice the difference between 5 and 6 nines. And let me show you why. How many people here have a mobile phone? The rest of you are like the Flintstones? What's going on? How many people have a mobile cell phone plan that's a US-based carrier? Yeah, so every single US-based carrier, at least as of last week when I looked it up, offers 2 nines of availability on their cellular network. And that's like really good, right? Because when's the last time you were like cursing out your cellular provider, right? You just refresh the page, right? It's fine. Most of you have never noticed that your cellular network provider only gives you 2 nines of availability. And that's pretty impressive because they're like microwaves in the air, right? Anyway, so your mobile phone most likely has 2 nines of availability. Now, let's say that you are an organization that has an unlimited budget with unlimited resources and unlimited time in the world. And you have managed to create a 100% reliable network connection between every cell tower in the United States with like multiple fiber cables and failover and redundant switches. You've spent billions of dollars to make this happen and invested countless hours and countless resources. Guess what? It's a simple math function. Your users will only ever experience 99% availability. Because if you have a 100% connection to the cell tower, but the cell tower has a 99% connection to your users, they will experience the least common denominator. They will experience the least of those values in terms of availability. So I can't possibly experience your 100% availability because I'm governed by a less reliable system. So how do you determine how much risk a service is able to tolerate? I said there are exceptions to this, right? Like airplanes should probably be 100% reliable. Medical devices should probably be 100% reliable. So how do you determine how much risk a service can tolerate? Well, there are factors to consider like fault tolerance, how many users do we have? Are we capable of doing A/B testing? Do we have circuit breakers in place? And a lot of these are actually discussions that happen with the software engineers and the product managers in collaboration with the SREs. Your acceptable risk dictates your service level objective, and then your service level objective mathematically corresponds to this thing we call the error budget, which is how often can your service be out of SLO. And if you choose a really, really high error budget, it means you have lower availability, but you have a higher risk tolerance, so you can push features faster. If you choose a really, really high availability target, it means you have a very, very low risk tolerance, which means that 1 or 2 bad deploys might put you in a mode where you can only deploy availability and reliability improvements instead of delivering new value. So as long as SLOs are met, feature releases can continue. But when an SLO breach occurs, it's not like we stop deploying code, but all of the code that we deploy has to focus on reliability improvements. Right? So this is a common misconception is people think, oh, well, you violated your SLO, you're done writing code. It doesn't work that way. You're still writing code, but you can only write and deploy code that focuses on improving the reliability and availability of the system. So there's always a difference between the actual uptime and the calculated uptime. The difference between the actual uptime and the calculated uptime is what we call the error budget. So this is a very pretty version of an internal graph that I stole. So we have an SLI, which is the requests that are under 300 milliseconds. So the dashed line at the top there in the red chart shows us like at any given time, are we above or below that line? In the middle chart in the green, we actually see kind of more of the binary representation of that, which is like, are we up or down? And then at the very bottom in the gold chart, we can see our actual budget. So as the quarter goes on, just like a bank account, we gradually get more and more and more budget. But then you'll notice we had a fairly large outage there, which correlates vertically on the screen, where we start to see a massive decrease in our budget. And that's because we had a number of requests that were over 300 seconds, which dropped us far out of compliance for our SLO, which then caused us to gradually burn through our error budget, eventually reaching 0. And at that point, the service was not allowed to deploy new features. They could only deploy availability fixes. Another key piece of the SRE story is this thing called toil. Toil is most easily defined as the thing that it's not. So toil is all of the stuff that you hate doing minus email, expense reports, meetings, and traveling, which is the way that I like to define it. But it has a few key characteristics, and I think some of you will start to recognize that you might have some toil in your job. Toil tends to be manual, repetitive, highly automatable, tactical, but devoid of long-term value. Toil is the kind of work that is tied to a production system that might make you happy right now, but generally doesn't advance your career or bring you, long-term knowledge and success. Now, I do want to take like a slight tangent because a lot of people think that SRE says that you shouldn't have toil. On average at Google, SREs have somewhere between 20 and 30% of toil. And that's like a pretty good target for someone who's like junior all the way up to senior or principal. Toil does have a number of bad characteristics. It can lead to career stagnation. It can lead to people feeling like they're not bringing value to the company. But it also has good things. Sometimes like you've had a really bad day where you've sat in meetings all day and you just really, really want to like feel that sense of accomplishment. And like SSHing into a server and like restarting a process will give you that sense of accomplishment. So not all toil is bad. Toil is bad at scale, right? Just like not all water is bad, but like water is really bad when you're drowning. So I like to think of toil the same way, which is like there is a healthy amount of toil, but it's important that we analyze it, that we study it, and that we try to eliminate it where possible. If once a year you have to run some complicated task that takes about 2 hours, takes one SRE 2 hours, and it would take you, say, 7 weeks, 100 hours of engineering hours in order to automate that. It would take you 14 years to recover that ROI. You're much better off eating that toil. So do the math and understand where is the ROI in automating something versus just allowing it to be manual, especially if there's a human decision-making process in the loop. So if this SRE stuff is interesting to you, we wrote a book on it. We actually wrote 2 books on it. You can get both of them for free in PDF format at google.com/SRE. If you want like ebook format, you got to pay for those, but PDFs are free. There's 2 books. There's the Site Reliability Engineering book. I like to call this the Theoretical Calculus book. This is the theory. This is the hand-wavy. These are the stories, a little bit of history. The Site Reliability Workbook, that's like the problem set. If you're a practitioner or a manager of a small team who's trying to implement this, that's the book that you want. If you're like a VP or a director who's trying to understand how this would fit holistically in your org, you want the Site Reliability Engineering book. But they're both free, so you might as well download them. So going back to the questions kind of posed in the outline or the session abstract is like, is SRE DevOps 2.0? No, it's not really trying to be. Like I said, SRE evolved independently from DevOps, but they happen to satisfy this kind of the same interface. Is SRE trying to overtake DevOps? No, there's many other ways that organizations can do DevOps. SRE is something that we at Google find to be very successful for an organization of our scale. And if you were in the previous session, the previous speaker talked about CRE, which is Customer Reliability Engineering, which is a division of SRE at Google in which we go to customers and teach them how to do site reliability engineering. So we've seen it be successful. It's by any means, not the only way that you can practice DevOps. It's just a way. Can I adopt both DevOps and SRE? Yes. Doesn't go the other way though, right? Like you may adopt VictorOps, ProdOps, and like you're not really doing SRE. But if you adopt SRE, you will be adopting DevOps. So to put it another way, like all squares are rectangles, but not all rectangles are squares. It's the whole point of an interface, right? I got this question once, is DevOps dead? Like, it seems like no one's talking about it anymore. I don't personally think that DevOps is dead. I just think it's becoming such a normal part of the conversation that we're not talking about it all the time. We have new buzzwords to talk about. Is my talk over? Yes. Yeah, so I think, I don't know, I'm going to look to Victor. I have 5 minutes for questions, or should I go straight to the discussion zone? All right, I should go straight to the discussion zone. Oh, yes. Please fill out the feedback form. Also, if you can't make it to the discussion zone because you have somewhere else to be that's more important, it's okay, I'm not offended. That's my Twitter handle and my GitHub handle, and also my email at google.com. So my DMs on Twitter are open. You can email me. You can send me a message on LinkedIn, that's also my LinkedIn. That's my internet. So if you have something that you don't feel comfortable asking, or you'd rather take some time to write it down, feel free to reach out to me on like any major social network or email, and I'll get back to you pretty quickly. If not, I will be in the discussion zone that is somewhere that I will be taken to. Thank you all so much for coming. I'll see you all in a little bit.